Yeah, okay. Okay. Unit 5. Alright, here we got Ohm's law. V equals IR. Easy way to remember that. Make the triangle. That's a pyramid right there.
Explain what they mean.
What was
Explain what they mean.
Explain what they mean? Well, V, that's your voltage. The symbol for that is just a V. Your current is I. That's going to be in amps. And your resistance is your ohm. That little symbol right there. You see that? That symbol. Good. Right. Easy to remember. This is what your circuit in series looks like. You got your resistors, you got your battery. Yeah, Emerson, hop in on this.
Yeah, it doesn't have to be battery. Any power source.
Okay, well, it doesn't have to be a battery. He's pretty smart. He knows what he's talking about. This is what resistors look like. For calculating the resistance in a series, you just add up all the resistors. Circuit in parallel. This one's a little bit tougher. Emerson might be able to figure it out though. Your calculation for this one is 1 over the resistor, add them all up, you get 1 over RP, that's your total resistance. Any power source, according to Emerson. Then you can combine them into one resistor.
Yeah. Yeah. And then we got all the formulas that we need for this video on a paper. But the two that he didn't talk about are the average current is the change in electric charge over the change in time. The resistance is P times length over area. I forgot what the P means. I'll look that up. But we have for the electric force is K, the charge of, this is 2 point charges a separate distance away. Force, the force between them is K, which is a constant, which is there, 9 times 10 to the 9th. It's kind of important. First charge times the second charge, and that's all over R squared. So you got to remember that one. That's for electric force or Coulomb's law. And then for the electric field, the field equals that little fancy formula times the charge. So that little fancy formula is KQ over R squared. Yeah, KQ over R squared, and that equals the electric field. So, got anything to add, James?
No, I think you covered it pretty clearly.
Oh, good.
So now you also have your power equation. P equals IV. P is your power. It's measured in watts. I is once again your current in amps, and V is your voltage. And it can be calculated with 3 different formulas. P equals I squared times R, or P equals V squared divided by R. And, oh yeah, those 2 right there. And P equals IV is your main one. So it's whatever is given to you.
Because according to Ohm's law, I equals V divided by R. And that's where you get that right there. Because if you substitute for the I, V over R, then it'll be V times V over R. And that's, you can use the same thing to do the I squared R. So,
Unit 5.
physics. Alright, now for the little problem thingy. Yeah. It says light bulbs of fixed resistance 3.0 ohms, 6 ohms, and 9 volt battery, and that was 3 ohms, are connected, and there's a switch as shown in this schematic diagram, and the switch is closed. I drew it just so you could see it, but the switch is closed. And so number 1 is, or letter A, is calculate the current in bulb A. And so we're going to use the resistance formula to find out the total resistance, and then we're going to work backwards and calculate the current in bulb A. that's A, that's B, that's C for the light bulbs. So to get this, you're gonna have to make these, because the switch is closed, you're gonna have to make these both 1 resistance, and then once you get those 2 down, because those are in parallel, then we can add these, make those 1 resistor, add those in series. So you're gonna do 1 over the total resistance equals 1 over 6 plus 1 over 3, which according to my calculations is going to be 2. So when we draw it, you're going to draw another kind of schematic thing. And this one we haven't touched yet. So this one is going to be, that's a battery, still 9 volts. This one's going to be 3 ohms. This one's going to be 2 ohms. And we're going to have to add those. And then when you add them in series, you just add them. So it's going to be this one with 1 resistor of 5 ohms. And once you calculate, this is 9 volts, and if you use V equals IR, you can use for this resistor right here, the voltage, which is 9, equals the question mark and times 5. So you're just going to do 9 divided by 5, which is going to be 1.8 amps. So it's going to be 1.8 amps. So because in a series current is the same throughout, this is going to be 1.8 amps, this is going to be 1.8 amps, and so you're going to calculate the voltage drop using V equals IR again. So you're going to find the voltage, so you're just going to multiply 1.8 by 2, which is going to be 3.6 volts, and this one right here, 3 by 1.8, which can be 5.4, and if you add those volts up, it's going to equal the total of 9 volts. Then you're going to work backwards one more time, and you're going to split this resistor into those 2 resistors. So if you take it over here, it's going to be, and in parallel, the voltage stays the same. So when you draw it, it's going to be, we just have to find the current in bulb A. The current in bulb A is 1.8 amps. And so, yeah, that's for the first one. So for letter A, it's 1.8 amps. Justify your answer. Which light bulb is brightest? Justify your answer. So for calculating the brightness of a light bulb, you're going to use the power equation. P equals IV, so current times the voltage is going to equal your power in watts, and amps and volts. And so you're going to have to go through and you're going to have to find the kind of like what we did up here. You're going to have to take it from this into this, the complete schematic. Because the switch is closed, I just didn't draw it as that. And so there's the battery, 9 volts, and we learned from the previous problem that this is 5.4 volts, 3 ohms, and 1.8 amps, and that's going to transfer over 5.4, 3 ohms, and 1.8 amps. This one is 3.6 volts, 2 ohms, and 1.8 amps. And so when we go back over to here, we learned from the original schematic that this is 6 ohms. We learned from over here that it has 3.6 volts. This one is 3 ohms, also has 3.6 volts because in a parallel it's the same voltage throughout. So you're going to use V equals IR, but you're going to do I equals R divided by V. So you're going to do 6 divided by 3.6, which equals 1.6 repeating amps. Then you're going to do the same thing here. So 3 divided by 3.6, which is going to be 0.83 amps through the whole thing. So yeah, and then so you're going to use power equals current times voltage. So you're going to do 1.8 for the bulb A, and 1.8 times 5.4. 1.8 times 5.4 is going to be equal 9.72. Then you're going to do 3.6 times 1.6, which is going to be 5.76. These are all in watts. And so you're going to do 3.6 volts again times 0.83 amps. Maybe 2.98. So this is going to be, bulb A is going to be the brightest light bulb. And it says justify your answer. And so you can say that bulb A is the brightest because it has. Okay, so correction. When I said that current equals resistance divided by voltage, I messed that up and I did it backwards. The answer is still A with 9.72 watts, light bulb A, but current is voltage divided by resistance, so the current is not 1.6 amps, it's actually 0.6 amps, and the current is not 0.83 amps, it's actually 1.2 amps for the respective light bulbs. So when you do the problems, these ones are wrong that I did previously. It's 3.6 volts times 0.6 amps equals 2.16 watts and 4.32 watts for bulb C. So that's the correct way to do it. For this next part, we're going to, part C says switch S is opened. So the switch is opened by clicking the appropriate spaces below. Indicate whether the brightness of each light bulb increases, decreases, or remains the same. Explain your reasoning for each light bulb. So it says bulb A, does it increase, does it decrease, or does it no change? So just put a check mark in each, and it has one for light bulb B and light bulb C. So what we're going to have to do is calculate the power and see relative to the previous one if it the brightness of the light bulb changes. If the power goes up, then the brightness will also go up, and if the power goes down, then it'll decrease. And so for switch C, because in the schematic they will open the switch, we know that switch C won't get any electricity to it, so we know that the bulb will go dark, meaning that light bulb C will decrease, and we just know that because there will be no current running through it. So we can say, and it says explain your reasoning, so we can just say no current equals no power, because in P equals IV, if I equals 0, then P equals 0 as well. So we know that one for sure, and then we will have to go to A and B. And in the schematic, if switch S is open, then it essentially closes off that part, so it just is two resistors or light bulbs in series. So we can redraw this as a 3 ohm resistor and a 6 ohm resistor. 3 ohms, 6 ohms, and we're going to have to redo the circuit analysis. So we can say, go in and say that there's one resistor which is 9 ohms, and because V equals IR, the voltage, which is 9 volts, and the V over I, R, V equals IR, and that means current times resistance equals voltage. If you want resistance, then you find voltage over current, and likewise for current, then you do voltage over resistance. But if you want to find the current and the voltage going through this, because it's the only resistor that it's going to have 9 volts of power traveling through it, and you want to find the current, so you cover current and voltage divided by resistance. 9 divided by 9 equals 1 amp. So we're going to have 1 amp, which you're going to go back through here, and they're both going to have 1 amp because in series the current is the same. Then you're going to do circuit analysis. V equals IR. V equals IR. So 3 times 1, 3 volts. This one's going to have 6 volts. And that's the voltage drop across each resistor. So for P equals IV, we're going to have 3 times 1, which is 3 watts. And this one is going to be 6 watts because of 1 times 6. So relative to previous problem, light bulb A, which is right here, and B, which is right here, light bulb A actually decreased. Some might think it increased, but it actually decreased because it had 9.72 watts earlier. So because the actual resistance went up, because in parallel there's actually less resistance. So this one decreased, and light bulb B was earlier at 2.16 watts, now it's at 6 watts, so that one increased. And that's just because there's the resistance on this bulb went up, so there was less current going through it, and the overall resistance went up, but because it's only going through this one and this one, rather than going through a different one in parallel, then it actually increases the brightness of this bulb and decreases. And, yeah,